I'm Eric Walenza, founder of IoT One, and this is the Industrial IoT Spotlight. Every episode, I interview one expert about a project that is impacting businesses today. Visit us at iot1.com to learn more, or email me to start a discussion. Welcome back to the Industrial IoT Spotlight. I'm joined today by David King, CEO of Foghorn Systems. Foghorn is an edge analytics solution developer. Today, we're going to be looking more closely at their technology. During our last podcast, we covered the company, the value proposition, and how they work with customers. And in our next podcast, we'll be diving into a specific use case. But today, the focus is technology. David, we've gone through your business. Now let's look at the technology. What is unique around the edge environment as opposed to the cloud environment from a technology perspective? And which aspects of that is Foghorn developing as opposed to working with partners?
The core invention that Foghorn launched to the market last year really revolved around delivering a much higher value compute layer at the edge than had previously existed. So the core invention, if you will, that underlies Foghorn is a technology called complex event processing, or a CEP engine. Our CEP engine was built from scratch to be able to run in extremely small footprint, compute footprint, and do extremely high-speed processing on streaming data. That was really the core invention. And the reason that's important is because all the CEPs that have been developed prior to Foghorn really were developed in a cloud environment over the last 10 or 20 years as, people move enterprise workloads from data centers to cloud environments. Almost all of the compute technologies invented, right, like CEP in the cloud environment, were built in huge compute, platforms. That is where you had infinite compute memory and storage available. So these stacks typically ran in 10 or sometimes hundreds of gigabytes of memory, and they were trying to grab massive amounts of data, right, from all over the web or from massive databases built in the cloud environment, and to then be able to process that data. So in that context, right, IIoT, where you have a tremendous amount of data being produced at the edge, all the edge systems in that environment were just frankly doing a little bit of filtering and normalization, but all of that data had to be sent to the cloud to do the processing. So what Foghorn decided to do was to take, basically attack the problem at its core, which is you can't take these big, massive stacks developed in the cloud and try to put them right close to the source of industrial data. I mean, you could put them on-prem in a big server box or data center, and certainly if you have a data center, then you could run some of these big stacks in that environment, but you're still talking about shipping a tremendous amount of data across a network, right, to get there, right, before the processing. So what we said is, look, let's invent something that is a CEP engine that can operate in, the CEP engine itself literally, runs in kbytes of memory, right? A whole stack, this three-layer stack that we have, which is the whole application, which is think of it as like a Dockerized Linux application, runs in, a couple hundred megabytes of in-process memory. So we are literally processing all the data as it's being produced in real time by these operation technology systems, the control systems that are taking in all the sensor data, also fusing it with other sources of new types of data like video and audio, any kind of reference data, right? Whether it's say GPS or, RFID data, whether it's MES data in the manufacturing environment. So we're taking everything as a stream into our system, processing all that data, applying the analytics, and now the machine learning on top of that, which a lot of people thought wasn't possible. And that's really just the core invention with the CEP engine that allows you to do very advanced kind of rules-based analytics, as well as aligning data for, for producing machine learning or AI insight based on algorithms or models that might have been built or trained elsewhere.
And then when we're talking about bringing the engine to the edge, is it typically right now that the analytics is being performed on gateway edge devices? To what extent are you seeing, or maybe we can first say, what is the smallest compute power or the smallest type of processor that can now handle Foghorn? And then are you starting to see these already on sensors, on individual devices? Or is it typically that this data is still streamed to a gateway or some sort of a localized computer and then processed at that point?
Yeah, that's a very good question. So the technology typically, the technology stack itself can run in like a smart sensor, right? So if you strip out a lot of the components, everything was built around Docker, so you can kind of install the components that you need and not other components that you don't need. There are smart sensors today that have tens of kilobytes or megabytes of memory where you could run portions of our stack like our CP engine, although it would be pretty hard to instrument it. But what we find is that a single sensor, right, isn't necessarily a good place to deploy because you're only getting insight from a single sensor, right? So typically what we see is that you want to be either operating in an IoT gateway, IIoT gateway, and we have a lot of partners like Dell and HPE and a lot of Intel's partners and ARM's partners that, literally hundreds of companies build small ruggedized IoT gateways, right, that are taking data off the control systems, right, out of the, right, probably sitting next to the protocol server. As the data is being published to the protocol server, we're also ingesting in line and then processing the data. However, our stack is sufficiently small footprint and sufficiently deployable that we actually are retrofitted in potentially to existing control system platforms. So there are systems, that manage a lot of machines, I'll give you two polar opposite examples. It could be, say, an elevator manufacturer that has a little control system gate control box that's running the elevator. The other extreme would be, say, let's, talk about the control system running a locomotive, right, which is a much bigger compute platform, but it's also doing a lot more processing. In those environments, you can't go put a second gateway to pull the data off. It's just it doesn't work from a business model perspective, or in the case of locomotive, from a regulatory or safety perspective. You can't go plug extra compute boxes into the control system. So there we have to actually install our software into a brownfield device, right? It's already, running the machine. And so the beauty of our approach by developing this ultra small footprint components that can run, as a easy to deploy set of Docker images is that we can basically install our software anywhere that Docker can run, and even install in bare metal, right, with a little bit more time to do the integration if it's a, kind of a high volume opportunity. So, it can run either in the control system. In fact, we're now being integrated in some of the world's leading PLC manufacturers' devices, right, taking data straight out the I/O of those devices. But the more common way that we have started is with IIoT gateways, right, from either x86 or ARM-based platforms like Raspberry Pi. We call them ruggedized Raspberry Pi. There literally are dozens, if not hundreds, of those kind of systems out there today from many, many manufacturers.
Got you. And then I suppose some analytical output from this system is going to be sent eventually to the cloud, most likely, right? Because you're going to want to interact with business systems, or you might want to store this as a time series. Let's talk a little bit about the privacy, security. You mentioned security as very kind of essential to the value proposition, that you reduce some of the risk of transferring to the cloud. But I suppose a lot of the data still is eventually, or some of the data or analytics is still going to have to make it to the cloud. What is the role of Foghorn? Are you typically working with another platform which would be providing kind of the data management? Or is this something also that's built into Foghorn, where in the cloud you're going to be the end managing that customer's analytics data? How do we work after we get out of the edge with this data? Where is the role of Foghorn? And then how do you work with partners as you're moving into the cloud or managing data in the cloud?
The customer would really be developing the analytics, machine learning, AI algorithms, running on the edge data through the Foghorn system. But you're quite right. The metadata output of that, the results, if you will, do need to be published somewhere. And in many cases, there are many customers actually who don't want that data ever going to the cloud, either public or private, so they keep all of it on-prem. I can cite many customers, especially in the oil and gas and the energy industry, where that's the case. Others, of course, will want to persist the data in either a public or private cloud. So we've built connectors to publish to many, many, many different destinations, right? So all the traditional kind of public cloud interfaces like AWS, Microsoft Azure, SAP HANA. We have, Hadoop file system, Kafka. We publish to both public and private cloud repositories, if you will. We also built special connectors to things like OSIsoft PyDB, Pi database, because that has really become kind of a worldwide standard in a lot of process automation industries. So we've built a lot of connectors to these different commercial clouds, if you will, as well as open source interfaces like, Hadoop and Kafka, HDFS and Kafka. But, we can literally in a matter of days write a connector to any place that you want us to send the data to. The whole point, though, is to send kind of encrypted metadata across the network not, raw OT data or even processed OT data, because that in many cases is critical infrastructure data that the business may not want exposed, right? You've already got a lot of IT exposure of data, right? You hear about, cybersecurity threats and breaches all the time. And there's a lot of concern, in some cases paranoia, about this whole idea of, making all the critical infrastructure, IIoT, environments now connected into an interconnected environment. So there is really, I think, a generic need, not only to reduce data for data reduction purposes, right, to reduce cost, but also to reduce cybersecurity risk exposure.
Let me ask a question a little bit off the edge here. I'm not sure if this is something that's really core to your technology that you thought a lot. I'm sure that it's something that you're obviously deep in a lot of areas, so that you have thought about. But blockchain, is this a technology that you see as really essential or impactful in terms of edge computing, or do you see? Let me ask two questions. One is, or do you see this as something that can be solved without the blockchain using existing computing methods? And then second question, speaking with a company called IOTA recently, which is a blockchain company that is focusing on machine-to-machine transactions, so microtransactions. Is the financial transaction between devices on the edge, is that an area that Foghorn is looking into? Maybe we can handle those questions separately, but I guess for me, they're both a little bit related to blockchain.
Where blockchain applies in IIoT is typically in the security domain, right? So there are many companies that are taking very novel approaches to apply blockchain technology to ensure essentially secure data, right, that's being produced and transferred. So what Foghorn's doing, right, with basically, complex event processing driven analytics and machine learning and AI, it's really orthogonal to that, right? I mean, to the extent that we're getting access to, if you will, the raw information, what I call the dark, dirty OT data, and we're doing the data cleansing, filtering, normalization, and conditioning of the data such that we can execute real time, right, analytics, machine learning, and AI capabilities on that data, right? So we're doing all of the front end so that you can process the data. Now, once we've done our processing, where you want to then, send that data to or persist it, right? That's exactly where blockchain and other security technologies enter the picture, where you want that processed metadata to be, persisted and transported in as secure a fashion as possible. And so this kind of microtransaction you talk about is where that data gets passed, right, from our stack somewhere else. But you don't need blockchain in front of us, but you do need blockchain after we produce the insight, right, before you want to send it somewhere.
So your technology is, as you mentioned, on the market just as of last year, was it? So what are we looking forward to in Q4 2017 and 2018? What do you have in the near-term pipeline in terms of new capabilities? Help us understand a little bit of as you envision it, the technology development path for Foghorn and for maybe fog computing in general.
So in 2016, actually, I think late Q3, we came out of stealth mode in mid-2016. We launched our first product, the Foghorn Lightning 1.0, was shipped about a year ago. And that was really the first big invention, which was the CEP engine, the complex event processing engine, which could do very advanced complex rules processing, right? So this is analytics applied in the OT or the industrial domain to supplement what companies were getting out of their existing legacy control systems. That was the first big invention. And, being the ultra small footprint, ultra high speed product that became Lightning, we got a lot of attention because we were now talking about doing a lot of the analytics right there at the edge rather than transporting to the cloud. The second big innovation came about in the middle of this year, 2017. We introduced our machine learning framework on top of that CEP engine, right? So the CEP not only allows you to do this very advanced kind of programmable rules engine functionality, it also allows you to align the data, right? Condition align data to execute machine learning and other AI algorithms, right? Whether they're developed in TensorFlow or whatever the environment you built the models in, you can execute them in our platform. In fact, if you give us a beefy enough server at the edge, that is like a small, HPE or Dell, Intel-based, x86 gateway, we can actually even train models, right, of a certain complexity at the edge. So, training and inference, but certainly models that have been, built and once models are built elsewhere, right, whether it's in a cloud or data center environment, we certainly, even in a Raspberry Pi or tiny footprint environment, can execute an amazing number of algorithms on that streaming data, right? Something people didn't think was possible. So this year was really the year of machine learning. And I think what you'll see is a movement next year and the year after towards more kind of true AI in this industrial environment. Right? Because AI today really is, people talk about robots, people talk about, autonomous vehicles. But in the industrial setting, right, you're typically as an industrial operator, owner-operator, you're not really going to let machines reprogram themselves. You're going to want to have a gestation period where first you're generating alerts for operators to look at, the insight that our stack is producing to improve their operation, right? Things that the control system isn't allowing them to do or isn't catching today. Then the second step is probably to develop applications or some closed-loop functionality using our stack to send the signal back to an existing control system, right, to allow you to change the setting or perhaps turn off the machine. And that's really the first step towards what I call AI in the industrial world, which is first you got to prove out that this, that the insights that are being generated and the outcomes of what our stack is doing, are delivering value. But typically there will be a human intervention step before you fully automate all the processes.
So David, thanks for joining us today for this discussion of Foghorn's technology. The next part of our discussion is going to focus on a specific use case. We'll be referring to a project that you implemented in conjunction with GE. Looking forward to that conversation, which will be published on the Friday after this podcast. Thank you again for joining. Good day. Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. We help to accelerate digital transformation by advising business leaders on how to integrate IoT technologies into their operations and products. We appreciate your thoughts, suggestions, and of course your reviews. And if you have an interesting project, we'd love to feature you on a future edition. You can write me at eric.walenza@iot1.com.